Hello, hello everyone. Welcome to the stream. So let's start. Let me start with the to-do part. So today is 20th Feb. So read Uber paper. Then let me check. I have written it in my notebook. I have to implement a MySQL trigger actually. So learn MySQL trigger. Then to do app tables design. Mostly I will be using Postgres for this time. I'm just exploring it. So let's see. So first one is read Uber paper. Let me find it where it is. Java framework for Node.js. I actually need to read this one. We'll read this too also. And we'll move this to another screen. Actually, this is my package that I have created. And if you are interested, you can try it. And it is open for contributions. Thank you for trying. If you try actually. It was my try to create a project, actual useful project. So let's see. Okay, so where it is. That was actually system. Let me check my history. Yep, that was this website. Highly scalable or not actually. Let me see. Yep, that's the same one. Let me check for. This is from yesterday, or it is day before yesterday. So let's see. This is fan out mechanism of Instagram actually. The paper I was reading. Yep, this one. Design Uber, because I guess they updated their website. Yesterday it was different. I don't know. Let's see. So designing Uber. This is a case of okay. In scope, rider should be able to view the wait a second. View the available rides in nearby location as shown in the image below. Showing nearby riders should be able to request rides from source to destination. Nearby drivers will be notified of the ride. Confirm nearby drivers, one of them will be confirmed pickup. Estimated time will be shown for customer when a ride is dispatched to pick up the rider. Once the trip gets completed, the rider is shown the trip details such as a trip map, price and so forth in the rider screen. Out of scope automated way of matching drivers to riders, taking factors such as new drivers and riders into account when the rider is dispatched. Architecture in order to design the system it's imperative to define the life cycle of a trip shown in the image below. Okay, rider booster nearby drivers are shown, enter pickup and destination location. Okay, ride is requested, rider drive cancelled, rider get dispatched, arrival ETA is shown to rider, track on going trip, rider cancels. If rider cancels, then end trip, then show trip map, life cycle of a trip. Okay, we can build the following components to support this trip life cycle. This component will work together to meet the requirement of building the rider heading system. Drive location, where the component will be responsible for managing the changing driver location. It will ingest the messages emitted by the driver Uber app containing their current location and update the car location index the trip dispatcher. It will be responsible for handling the trip request from user and dispatcher driver in response to those requests. Okay. Arrival ETA calculator, the component will be responsible for calculating the ETA. So we have trip dispatcher. It will be responsible. It will be responsible for handling the trip request from user and dispatch. Okay. Dispatcher driver in response to those request arrival ETA calculator. This component will be responsible for calculating the ETA for the driver to reach the ride. Once the driver has accepted the ride, trip recorder, it will record the GPS signal transmitted from a rider when the trip is in progress. Okay, this GPS signal will then be recorded. Let me write this in my notebook. Not notebook, actually notes. So trip recorder, it will it will record the GPS signal transmitted from a radar when the trip map match. This component will be responsible for matching the trip on the actual map using algorithms specialized for this purpose. Okay. Basically, it will use the recorded trip information from company the price which user have to pay for the trip. The component mentioned above can be grouped into three major categories: pre-trip component, on-trip component, and data storage. And data storage, we have shown each of the component. The pre-trip is driver location manager. Okay. Arrival ETA calculate trip dispatcher, on trip recorder price calculator map matcher data storage trip recorder. High level component, high level design. Pre-trip component, this component will be supporting the functionality to see the car in the nearby location, dispatching the ride on user's request. The location of the cars can be stored in an in-memory car location index explained in a data section, which can support high read and write request. The driver app will keep on sending the update car location, which will be updated in the index. The index will be uh, queried when rider app request for nearby. Okay, so once again, the driver app will keep on sending the updated car location, which will be updated in this index. Okay, the index will be queried when rider app request for a nearby car or place. Okay, the sequence of operation leading to the ride dispatch is shown in the image. So, 1st, we have, 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 so, 1 So we have a driver and a rider. Update a driver's current location. Select a driver location manager. Then we have index the updated driver location car location index. Then we have fetch the nearby cars with a specific radius. Place for a rider. Okay, so this is for driver and this is for rider. Requires the nearby car to give location. Place query to fetch the nearby cars using the sharding key. Okay, fetch the nearby car with the specific radius. Return the list of nearby cars and show the nearby cars as shown in the image below. Request for a ride. Fetch the list of nearby cars. Notify driver of the ride request. Confirm the ride request for fetching the estimate time for the car to reach the ride. Okay, return the computed ETA. Applies to logic to compute the ETA. Provide the driver info sequence. Okay, then we have this step. Okay, so there are three sequence of operation before a trip start as shown in the image above. Update driver location, list nearby drivers and request for a ride. Operation involves updating the driver location and driver keeps changing the location. The second sequence comprises the steps involved in fetching the list of nearby drivers. The third sequence includes a series of steps involved in requesting and dispatching a driver car location index. Will maintain driver location in a distributed index which is spread across multiple nodes. The driver information contains the location, number of people in the car, and if they are on a trip in aggregate as an object. These driver objects are distributed across nodes using some sharding mechanism. Okay, along with replicas. Location index. Each node maintains a list of drivers objects which are queried in real time to fetch the list of nearby drivers. Each node maintains a list of drivers nearby. On the other hand, these objects are updated when the driver apps updates about their location. Their location and any other related information. Some interesting characters index register. It should store the current location of all driver and should support fast query by location population and driver trip status. It should support a high volume of reads and writes. Okay, the data stored in this indexes will be ephemeral and we don't need a long-term durable storage. Updating including location data, ETA and estimated time calculator. We need to show the pickup ETA to users when the ride had been dispatched by taking factors such as route traffic and weather into account. The two primary component of estimating it. ETA given in the destination variable, computing the route from origin to destination with the least cost, which is function of time and distance. Estimate the time taken to traverse the route. We can start by representing the physical map by a graphical representation to facilitate route computation. We don't do this by modeling by every intersection by node and each road segment by a direct edge. We have shown the graphical representation of the physical map in the image below. We can use routing algorithms such as Dijkstra algorithm to find the shortest path between source and destination. However, if they're using division algorithm, that the time to find the shortest path of n nodes is a big problem, which renders this approach infeasible for the scale at which this ride shaping performs. We can solve from a partition the entire graph, computing the best path within partition and interacting with just the boundaries of the partition. In the image below, we have shown the manner in which the approach can enlarge a partition. Once we are aware of the optimal route, we can find the estimated time to traverse the road segment by taking traffic into account, which is a function of time. Whether the real life event which we use this traffic information to populate the edge weights on the graph as shown in the figure here. One trip component, this component handles the process which are evolved from start to complete of the trip. It keeps track of the location of the ride when the trip is in progress. It also is responsible for generating the map route and computing the trip cost when it gets completed. In the image below, we have shown the sequence of operation which are evolved while the trip is in progress and also when it has completed. The driver app publishes GPS location when the ride is in progress, which is consumed by the trip recorder through Kafka stream and persist in the location store. Upon trip completion, map fetcher generates the map route using the raw GPS location. Okay. Notifies trip completion. Was the process of generating the route map has the GPS location for the trip. Applies a map matching algorithm to generate the map route, return the map route. Okay. There's the price of the trip. Return the map and the price information of your Kafka stream. Then we have location store and data model. This store component will be responsible for storing. Hello everybody. for storing the string of GPS location sent by the rider driver app. While the trip is in progress, some of the characteristics of this tour are listed below. It should support high volume of ride. The storage should be durable. It should support time series based queries such as the location of a driver in a given time range. We can use data stores such as Cassandra, okay, for persisting the driver location, thereby ensuring a long-term durability. We can use combination of as the partition key for storing the driver location in the data store. This ensures that the driver location are ordered by the timestamp and support time-based queries. We can store the location point as a serialized message. Okay. Map nature. This module takes in your GPS location as an input and output position on road network. The input GPS signal comprises of latitude, longitude, speed and ports. On the other hand, the positions on the road network comprises latitude and actual road, longitude and actual in the road segment, ID, road name and direction heading. This is an interesting challenge in itself as the GPS signals can be far away from the actual road network. Future examples are shown in the image below, where the box on the top left corresponds to an urban canyon situation caused by tall building, and the one in the bottom right is due to the sparse GPS signals. Okay. The map generated by the map method is used for two major use cases: finding the actual position of the driver on the road network, calculating a fare price. To solve the map matching problem, we need to determine the route which the car would have taken while being on a trip. We can use the approach of hidden Markov model to find a globally optimum route selection of the road segment. Hello, Ahmad. Welcome to the stream. Hope you are having a good day. It's raining. No, I have added a audio, background audio. Hope you like it. Cool hub page. How do I make it like yours? Do regular coding. That's the simple solution. I used to do a lot of when I used to do CP, I used to solve 2 or 3 questions, maybe 5 questions daily. So I used to push all the questions whenever I'm done with the coding and the description of it. So that's why I have that much greenery in my profile. Thanks, no worries, buddy. So for question you used what? I used to code on lead code and code forces. Initially I started with lead code, then I switched to code forces. Then I stopped doing it. Now again I have to start, but I am busy in Monstack for now. That's my I am professionally a full stack developer, so I'm more into now Monstack. So just I'm exploring it. And this is like yep. Uh, I'm currently doing a to-do multi-role to-do app for Indeed one. As in that one, I require a user or multiple users. So for that exploration, I thought of creating a simple application to-do app that will have a multi-role that I will start from tomorrow's stream, like building database and all those stuff. Let's see. Great. What are your timings? Office timings or streaming timings? Maybe you are asking of streaming timings. So I usually start from 10:30 or 11 to 1 o'clock. Like daily I do for uh, 1.5 to 2 hours stream. And on weekends I do 4 to 5 hours stream on Saturday, Sundays. Sunday I usually take break, but on Saturday and Friday night I do a stream of long hours. Nice. What motivates you to or inspires you? Um, I don't know. I just love coding, so I just code. Like I enjoy it in simple words, and it's I like to do that. Sit on my computer and build. If you have any feedback about the channel, I will be happy to receive it. What was your first? Mm, Mine was Python actually. I started with HTML, CSS, and then I thought of. I actually don't know. I started in 2020 in my first year. So as I was started with HTML, CSS, then JavaScript, then Python. Then then JavaScript. Maybe I learned React first few months. Then I switched to Java for DSA, and in currently I'm learning C++ Upstream, and I'm currently a full stack developer in Stack. Damn, it's just a regular path of roadmap or just you're doing this way. I don't know. Is that a regular path or roadmap, or is it just you're doing this way? I do lot of coding, so I actually don't know what the roadmap. I just whatever I find interesting, I just do it. Like now, I thought of reading some papers, so I read about Uber paper. Then I'm reading this Vercel one, and I have a to do. Actually, I write to do from here, and I also maintain it in my notebook what I will do, and that 90% is only reading books. Like I read books, development books, and all these stuff. If you want to nice any recommendation, That will depend on your tech stack, what you are more interested into. Machine learning, AI, and a dev book. Okay, so I dev book is I actually know about system design book. I'm not able to recall the name. Uh, Let me search it. Yep, this one. This guy book. He creates on system design and some interesting stuffs. I will leave the link in the chat. You should watch his videos. Maybe yep, this one. Thanks for taking your time for that. No worries, buddy. I'm happy to help you. And if you have any query, you can message me on Discord. We can have a call if you need any help. It helps a lot. Thank you, buddy. You can find me on LinkedIn or Discord, or you can mail me. If you don't mind me asking how much time it for you to make the dedicated portfolio, I mentioned that after considering basics of Python. Um, I actually don't know. I never focused on that all stuffs of building portfolio, that GitHub portfolio. I like to build projects, so I in my free time I plan it and build it. And I should I can't tell you, like I do this stuff. I I like to do this stuff, so it automatically happens. From Python, if you ask me, and if I'm able to recall, to be honest, in between I switched to cybersecurity. If you search my username Scott32K in hacker that try hack me and hack the box, you will able to find my name Bug Crowd. I used to also learn that one. So actually, I'm mixed up stuff. I explored a lot of stuff. So there is for me there was not a single path. I followed a multiple path. Then I am now into Monstack. You can pick one language that can be JS or React and start learning it, and after learning, like only learn 40 to 50% and then start building project. And if you are stuck in between, then just Google it and build a lot of projects in that single framework or a language. Then you will automatically export it. Which have multiple path. Also, it is expected that one makes one. But yep, single framework. But that is dependent on you what you want to achieve. I will recommend, if you have time, just explore it. If you are in 11th or 10th or in lowest standard, that can be 5th or 6th. Try exploring stuff like ML, AI. All these stuffs are growing a lot. So you can explore it, and after that you can choose one and then master it if you have time. Okay, so I got your LinkedIn connection. It will accept. I'm in first year, SEM to my first language C. Now learning. Yep, yep. I remember I was also learning C. That was me. So I'm in first year, SEM 2. Okay, so you are in SEM 2. So you have a lot of time. You have a lot of time. Don't worry. You try to explore some stuff, like um use YouTube for exploring stuff like what are the benefits, the future scopes and complexities and all these stuff. And in SEM 2 you can choose one, like DSA is the compulsory in every field, so you should stuck with DSA, and with that you can choose Monstack, Angular, React, SvelteKit and ML, AI, whatever stuff you want to learn. But for now, try exploring. As you are in first year, you have a time, so don't worry. Wait, I will accept your connection. Thanks a lot, brother. It feels better after listening to it. Thank you, buddy. And don't worry, like if you start doing it, you will automatically get the path. You don't have to search for it. You will automatically find when you start doing stuffs. To go now. Hopefully, see you tomorrow. Thank you. Thank you for joining stream. Take care. Bye bye. I'm like a bit tired, so we'll do this tomorrow only. Let me, and we'll only start with, we'll directly start with this only. 2102 and this will be to do. So thank you everyone for watching. Thank you for joining. Bye bye. Good night.